Welcome to Zero Knowledge, a podcast where we talk about the latest in zero knowledge research and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
This week we chat with Mark Tyneway about the project Handshake. But before we start in, I want to let you know about a newsletter called ZK Mesh that I think you might want to subscribe to. It comes out once a month. It's put together by myself and Mikera. We collect the latest research papers, articles, updates, and tools around decentralized privacy-preserving technologies, privacy protocol development, and zero-knowledge system research. At the moment, it remains just a collection of links, but we will be developing this over the next few months, so you should sign up now and stay tuned. The latest edition just landed today with a recap of what happened in May. And if you have new research that you want us to include in future editions, please get in touch. But in the meantime, just subscribe at the link that I shared in the show notes. And subscribe to the podcast as well if you haven't already. I've been told I'm supposed to say this, so now I'm saying it. So here's our interview with Mark all about Handshake. So today we're chatting with Mark Tyneway, who's a contributor to the Handshake project. So welcome to the show, Mark.
Awesome. Yeah, thanks for having me. I really appreciate it.
Great to have you.
Our hope with today's episode is for us to understand a little bit more about what this project is, what it aims to solve. And we also want to talk about some other kind of interesting, unique features like the Airdrop token distribution you guys did, maybe this concept of an Urkel Tree, which I thought was pretty hilarious when I first heard it. And there's a lot of topics we can cover. So I think as a start, I'm curious, what is Handshake? Is Handshake a company? Is Handshake a community? What is it exactly?
Yeah, I think more than anything, Handshake could be described as a community. There's no central kind of foundation. There are a few different companies that are kind of involved in the Handshake ecosystem. And it's pretty cool because each day there's kind of more people getting involved and there's more projects kind of popping up out of nowhere. So I'm really excited about the future of Handshake.
Was there a conscious decision to not have a founding company or foundation, or most projects go with that these days? And I guess in part they go with that because of legal requirements in doing an ICO. But what was that situation for you guys? And I guess even as a preliminary question, what was your involvement in the foundation of the project?
Yeah, so all of that came before my time, before I started contributing to the project. I do know that there was a conscious decision to not have a foundation. And it really just boiled down to kind of when you have a foundation, what are the long-term goals of a foundation? And when you have an organization that is trying to sustain itself in balancing that with the needs of the community. And will a organization start to try to put its own needs ahead of what the community needs for the project to grow as a whole?
It's like a perpetual, constant problem that I think you could encounter this in every industry, on every level, where you want to create a cool project, but you do need often this infrastructure for that project to exist. And then once you introduce that infrastructure, it takes up mind space and budget, and it affects strategy and all of that. I think that's not unique to the decentralized space. I think that you could see that with lots of entrepreneurial efforts in various industries. But what does it mean to not have one? This is really interesting. You must still hold common channels, certain IP. How does that exist then?
How do you pay people if you do pay people?
That's a really good question. So luckily we have people out there right now that are willing to pay for Handshake development because they're interested in building companies on top of Handshake. And they're also ideologically interested in what Handshake can do for the internet.
But what about is there a Handshake brand? Is there a logo? Is there anything that you wouldn't want some other malicious group to go out and pretend to be you? How do you deal with that?
Yeah, that's a really good question, and that's hard to solve. There is a Handshake logo. There is a white paper. and there is a website, and really all Handshake is it's just loose consensus on running code. So anything is really fair game to be changed by the community. But that's just my opinion. So other people in the community can have different opinions if they so choose.
Okay.
I think let's go to the core problem, which is DNS. This is a system that's been around more or less as long as the internet. And like, this is a thing that I often come back to DNS and like, since the start of my involvement in blockchain, whenever anyone asks me like, what's the killer app of blockchain? It doesn't really exist. I mean, first one is currency, and I think that's pretty obvious. But the second one that I always bring up, which is more nuanced, is DNS. Like, DNS is a huge problem that needs to be solved. And people look at me a bit blankly because they don't really understand what the problem is. Like, I can go to Spotify.com and that works, right? But what is the problem?
There's multiple problems. So one problem involves a monopoly over the right to create top-level domains. There exists some organizations today, like ICANN, and they do a great job. They faced some of the original governance problems of the internet, and they got through them all, and they really got the internet to where it is today. Handshake lets you buy new top-level domains directly from the blockchain, and then you can set up a root of trust that is rooted in the proof of work, and you no longer need to rely on ICANN or any currently existing registrar for your DNS resolution.
What would be the main registrars today? Like in the sort of centralized space? Maybe some listeners are familiar with them.
Yeah, so there's VeriSign. They're a really big one. I think they're making, I believe, $30-some billion per year. I should probably double check that, but that's the number that I recall off the top of my head.
Okay.
There's also
Gandhi is another big one. The weird thing with registrars in centralized spaces, there's like, I don't know how many like really top level ones there are, but there's a weird hierarchy where there's a few really top level, like they are the ones interacting with ICANN, like, you know, actually registering the domains. And then there's a ton of like lower level registrars that are more like end user focused, that are like localized to a market. Like the biggest Swedish registrar doesn't actually register any domains themselves. They just go to one of these other like higher level registrars and register their domains there. So there's this huge structure in how this happens. It's kind of opaque.
Where do like the GoDaddies live? Are they in that group that you just described?
Yes.
Yeah.
Yeah, they're kind of a lower level one.
Just for me to better understand this, like the DNS part of this is what ICANN does, right? Like that's the DNS itself, and then there's these sort of suppliers, or is the entire thing considered part of the DNS ecosystem, like system?
Yeah, so it's ICANN is really just at the top, and they kind of manage the root servers, and they kind of manage all of the paperwork and governance of the whole system. And they set up kind of like the guiding philosophies of how DNS works. And then they kind of create a marketplace for organizations to come in and sell domain names.
You can see it as ICANN has the permission to hand out names, right?
Yeah.
But
exactly.
then DNS is also tying an IP address to that name. So the registrar usually also provides DNS services, but not always. So you could buy your name from person A and then use person B for my DNS provider. And so I'm telling person B what my IP that I want to link to this name is. And that's not apparent to person A. And it's a kind of a complicated structure. And the DNS lookup isn't really related to the registrar anymore usually, or even like ICANN. Most people these days that I know of at least either use Cloudflare's DNS or Google's DNS. So these are like 8.8.8.8 is Google, 1.1.1.1 is Cloudflare. And so they're just like scraping up the names and IP address matchings from everyone in the world and providing that in one centralized point, so it's fast to look up anything.
Totally. They run highly available servers, and they're set up with Anycast, and they also have denial of service protection to prevent certain types of attacks that can spam the internet with requests, because there's a giant risk involved with running name servers, and it's kind of complicated. And we learned this firsthand by running our own public Handshake resolvers. And we noticed that people were doing this DNS reflection attack where they were spoofing the IP in the UDP packet header. And then that was basically tricking our name servers into sending tons of data at particular IPs. So it's kind of hard to run public name servers.
So what part of that hierarchy that you just described does Handshake cover? Is it the entire thing? Like, does it go from, indexing and allocating these names to handing them out? Or is the expectation that you create sort of an equivalent ICANN that's decentralized, and then there should be new companies that sort of like live between that and the users?
That's a good question. So Handshake is strictly a root zone. It's an alternative root zone. And what that means is you can buy top-level domains using the native coin, HNS, directly on-chain. And once you have a UTXO that represents that name, then you can write DNS records to an authenticated database, which then can be looked up and used as a DNS server. Because by running a blockchain full node, it also starts up a recursive resolver and an authoritative resolver, where the authoritative resolver is authoritative over the Handshake root zone. And then the recursive resolver, that's what you would want to point your DNS configuration at. That would be able to ask the Handshake authoritative name server for Handshake name data. And then it would be able to take that data and then recursively resolve out to an authoritative name server that's off-chain.
Like, the immediate thought I have here is, if I use Handshake and register a name, would it not, and it's written to the blockchain and it's within that system, would that still be reflected in other systems that are centralized? Like, if I went to GoDaddy after, I know it was a bad example, I don't know if anybody actually uses that, but if I went there after and looked up that specific name, are they connected, or am I completely off base? Is it just like a unique system?
Yeah, so Handshake is meant to extend the current DNS system.
I see.
If you are strictly using the current system, you will not be able to resolve Handshake names. But if you use a Handshake-based resolver, you'll be able to resolve all of the Handshake-based names as well as all of the ICANN-based names.
But what about visiting the actual URL? Would that still direct me in a traditional sense towards what I've registered, or do I have to go on a different system to actually access it?
So as long as your computer is hooked up to resolve its DNS through a Handshake resolver, then you'll be able to access the Handshake internet.
Yeah.
I see. So, but I would need to have it myself on my computer.
Yeah. So you can either have it set up directly on your computer, or your network administrator could have it set up, or you can do something similar to, say, the way that Cloudflare runs 8.8.8.8. There could be another company, or maybe even Cloudflare, that offers as a service the ability to just go into your computer settings and just change where your DNS is pointing. And you can do this on your iPhone. You can do this on Androids. All sorts of different devices allow you to go in and configure your DNS settings. So you just need to point your DNS settings to a Handshake resolver, and then it will be able to resolve all of the Handshake names as well as traditional ICANN-based names.
Does Handshake also deal with TLS? Do you also provide certificates on-chain?
Yeah, that's a really good question. So that's one of the biggest problems to solve right now for Handshake.
Okay.
is that there are no...
Because then that's a whole other world of industry that you can also replace.
Yeah. So that's part of the idea, is that as well as it being an alternative root zone, it's also a traditional or an alternative certificate authority system.
Yeah.
I have one more kind of basic question about like what it is and how it lives. Is there any way that like a browser would be able to help with any of this? Like, or is this completely separate from like the browser world? I'm just picturing like, is there any way that like, something like Brave incorporates something like this to make it easier for people to find it?
Totally. One of the Brave developers actually came to a Handshake community call maybe a month or so ago. And we kind of went back and forth talking about the different ways to integrate Handshake directly into Brave. And there's an interesting trade-off, because you can opt for more security or less security. And I kind of call this like a sliding scale of security based on how paranoid you are and how much you want to validate on the client side. So if you're extremely paranoid, then I don't think Brave would ever do this, but you'd want to run a full node. And then your full node would be validating every single transaction, making sure that every single state transition is correct, and then you'd have all of the data locally.
This would be like each individual Brave user running a full node.
Yes.
Got it.
So that would be really, really heavy to add to a browser.
Yeah.
I don't think it really makes sense to make browser users have to download potentially hundreds of gigabytes of data and do all of that processing and all of that extra networking.
But I guess another option would be that like something in the browser connects to full node somewhere else that can like handle lots of these. And I guess this would be almost like a service or it sort of starts to take a similar shape, I guess, to what you have with this ICANN and the... Exactly.
Yeah. So the next step up in better user experience, but you trade off a little bit of security, and
decentralization, right? Because it's like a slightly centralizing force.
Well, you can run a light client. You can run a light client. So by running a light client, you still maintain some decentralization, but you're not really validating every single, state transition, every single transaction. So a possible attack on this would be, somebody creating a fork, a proof of work based fork. So they would create a heavier chain, or they would like Eclipse attack you, where they would control all of your peers, right? And then they would be feeding you blocks. And then since you're not getting any of the transactions to actual blocks, you have no idea how the authenticated database, the Urkel Tree, you have no idea how that's being updated. So basically, people could potentially put whatever DNS records they want inside of the tree, and then they could be feeding you these blocks, and then they would be able to send you an invalid proof that would validate against the root hash that's committed to in the block header. Because the root hash, just like how Ethereum does it with their authenticated tree, Handshake has an authenticated tree that is committed to in the block header. So it's really important to make sure that you have like a bunch of peers when you're running a light client. So we've been talking a lot about how to possibly integrate a light client directly into a web browser such as Brave. And we have a project called SNSD, and it's a light client, and it's written in C, and it was recently upgraded to work on Handshake mainnet, and we're still in code review, just working on it and making sure that it'll work, just dog fooding it and stuff like that, making sure that there's no memory leaks, nothing like that. And that's one possibility. But the problem with that is that you're going to be adding a lot more of networking and potential computer usage just right into the browser. So if users are okay with that, that might be a good option. Another possibility to add into Brave is this idea of TLSA or DANE. And it's this old RFC back from maybe the early 2000s or something. So it's a way to basically remove the need for the certificate authority system, because the domain name holder themselves can commit to the TLS certificate in DNS. And as long as you have authentication through the DNS system using what's called DNSSEC, then you can directly trust the TLS cert that the server gives you when you're trying to connect with them, because then you can hash that cert and then compare it to the hash that is in DNS. And if they match, then you know that that is a trustworthy cert. And this idea, it was actually implemented in Firefox maybe around 10 years ago, and they removed it. It was because they really valued latency over authentication, because the security model of the internet, it's good enough. I'm not sure if you're familiar with that Google study where they talked about how like every extra millisecond that they would add to a search, it would cause the usage to drop off. So having to request all of this data over the internet and then do cryptography to verify, that would add additional latency, and the people kind of working on the internet didn't really want to make that trade-off because the security was good enough.
Just for your last point, I kind of missed how that linked back to Handshake. So you mentioned sort of TLS and DNS, but like, why would it be relevant kind of to your system?
So it would really allow Handshake to operate as a decentralized certificate authority.
Oh, wow.
Because the name holders themselves, they wouldn't need to rely on anybody else to basically sign off on a TLS cert for them. Right now, a lot of people use Let's Encrypt, which makes the user experience of getting a TLS cert a lot better because there's automation involved. You just kind of need to, they have this thing called Acme protocol that's, I think, is really interesting. But before Let's Encrypt, you would have to kind of send a bunch of emails back and forth with this company, and then they would pop out a TLS cert for you, and then you'd put it on the server, and then that's how it worked. And so with DANE or TLSA, it would remove the need for Let's Encrypt or these other services that provide TLS certificates.
And instead you would store that certificate on-chain on Handshake and store it together with your name registration.
So the way that Handshake scales is right now the Handshake blockchain is referral only. So if everyone wanted to put all of that data directly on chain, it would cause it to blow a lot. Really what that means, referral only, that means that you need to set up an authoritative name server that lives off chain, and everything can scale horizontally. So you would basically put like an NS record on chain and then an A record on chain, glue, then all of the additional data would live off chain. And the authoritative name server would be responsible for making that data available.
It feels like there's an opportunity lost in reusing the same key that you bought your domain with to generate a cert. Like if it lives off-chain, well, maybe you could still link those keys, right? I mean, that would be the ideal. It's like I have a private key. That's where I store my tokens. It's what I use to register my domain name, and it's my certificate generator. And therefore, I can instantly, like an observer, like looking at, okay, I want to find what IP this is. They can instantly see that this is all generated by the same person.
That's definitely doable. I think one benefit of using multiple keys would kind of separate risk.
True. Yeah.
And then if you're using the same key in multiple crypto systems, there might be unknown interactions between them where you can leak some bits of the private key.
Yeah, fair enough.
One interesting thing about Handshake names is that you can actually use a multi-sig to lock the name because it uses Bitcoin script under the hood. So you could actually have like a 3 of 5 locking your Handshake name where you keep, 2 of those keys really, really cold, and you could even distribute them between people or whatever. And then maybe you can use that third key kind of for what you're describing.
Why did you go with Bitcoin script? It's a side question, but
yeah, that's a good question. So Handshake is a fork of Bitcoin, and it includes Bitcoin script, all of the SIG hash flags. It's UTXO based, proof of work.
I thought the client was written from scratch, though. It's like written in JavaScript, I believe, or like the first one.
Yeah, so it's a fork of Bitcoin. which Bcoin is an alternative implementation of the Bitcoin protocol. And it powered Purse.io for many years as the backend, and it was serving all of the customers very well.
Do you know why the decision was to build it in JS and not in something else?
I mean, that's a good question. The lead developer is really, really talented at writing JavaScript.
Oh, okay.
I really haven't seen any JavaScript better than the JavaScript that he writes.
Who is that?
His name is JJ.
Okay.
Yeah, and if you go and look at the code, a lot of people like to complain about JavaScript, and I completely understand because sometimes JavaScript can be really crazy, but I really think it's the cleanest JavaScript that I've ever seen.
I was at a conference, I can't remember which, and I don't actually know what Joseph Poon's involvement in Handshake is. I just know it's something. And I was talking, I think it was him that I was talking to, and I was asking him why it's written in JavaScript, and he said, because people like you will complain about it being written in JavaScript and write something else. So it's a free way to get multiple implementations.
Yeah. Yeah, there's a work in progress Rust implementation, but it's still pretty early. We're hoping that as the community grows, more people start working on different projects. There's been interest in kind of Go tools. There's been interest in Rust tools. There's some people that are popping up that are starting to write some tools in Python. So I'm confident that given enough time, the mature kind of tooling ecosystem will appear.
Yeah.
How is Handshake different from ENS or Namecoin or like some of these other name systems like Unstoppable Domains? And I mean, I think one, I can already highlight one, which is like you have your own blockchain, which seems to be somewhat unique from at least some of them. But yeah, what's the difference? And do you interact with them in a way?
Yeah, I've met some people that work on ENS, and I think it's a really cool project. I think that Handshake compared to ENS, they kind of serve different purposes, in my opinion. ENS it's built on Ethereum, and one benefit of that is that it has a lot of other projects can kind of plug into other things that are built on Ethereum. But one downside of that is that, Ethereum, the nodes are rather expensive to run. So Handshake was built in a way where it's meant to keep the nodes really cheap. You can't really do much client-side validation with Ethereum. It's really hard to have like light clients.
Is that because everything's written in smart contracts, or like why is it hard to have light clients?
No, it's just the infrastructure isn't really there to serve them that well. I mean, light clients exist and you can query everything. But even the light client is heavier because it's generic, because you're supposed to be able to query anything and you're supposed to be able to get a Merkle proof of any request that you're making. And this is something that I've been preaching now for 2 years, which is domain-specific blockchains, right? It's sort of, if you're building with one singular purpose in mind, you can also tailor everything to that. The performance of the light client, the data structures on chain, and everything else, right? So you can maximize performance for this specific problem.
Totally. So another difference between ENS and Handshake is that ENS is really controlled with a multi-sig, whereas Handshake is kind of controlled by proof of work.
What's the difference between, like, what is Namecoin or Unstoppable Domains? Are they related to what you're doing?
I think Namecoin is really cool. It's I think it's the first fork of Bitcoin that ever existed, and it's a really old project, and people are still working on it. I think it's pretty awesome, but one of the main problems with Namecoin is that there's really no way to do light client proofs with Namecoin. Handshake was really designed, like what Frederick was saying, to allow for mass adoption through these light client proofs, because it's just really hard to ask a lot of people to run full nodes just everywhere on all the devices.
I think maybe this is just because they haven't gotten to it yet, but I never heard anyone in ENS world talk about integrating with the legacy DNS system. Like you said before, that Handshake is sort of an extension of DNS. ENS is DNS on Ethereum. I've never heard them talking about, oh, this is supposed to be breaking out of Ethereum and I'm supposed to be able to replace any domain or any DNS request. I mean, as far as I know, there doesn't exist a traditional DNS resolver that resolves ENS names. I mean, you could build one, but I don't think it has been built. It doesn't seem like a first-class citizen for them. So it's sort of a different focus, maybe more than a different technology choice.
There's a philosophical difference between the two projects, I think.
Yeah.
ENS is very committed to only creating one top-level domain, whereas Handshake is really all about anybody can have a top-level domain. .eth was actually reserved for the ENS team through part of the airdrop, and they were the first name to be claimed and then also updated on chain. So you can actually query .eth on Handshake and nothing will return. They didn't write any records, but I am hoping that they do set up an authoritative name server that does bridge to ENS. Because they do have a project. It's a plugin for, there's like Go DNS tooling, and they've got a plugin for a Go-based DNS server that you run it next to Geth, and then it's able to call into Geth every single time and acts as an authoritative name server on top of it.
Well, that's cool. And then something there is in progress. I'm happy to hear.
Totally. When it comes to unstoppable domains, I know that they're building a registry on top of Zilliqa as well as Ethereum. And I know that they're working, I think they own .crypto on Ethereum. And there's actually early on in kind of Handshake, .crypto went up for sale. And they popped into the community and they were really interested in buying it. I'm not sure if they ended up doing it, but there's kind of some back and forth. So yeah, maybe they have .crypto on Handshake as well.
Digging in a bit more to how Handshake works, and I think it's also relevant in comparison to the other systems. There's this auction system. It's sort of, ENS also has an auction system of some sort, but how does that actually work? Am I buying a name? You know, you already said there's a rollout period, so I'm not really buying it forever. In traditional DNS, I usually buy like 1 or 2 years, but then it's also like a cost. In ENS, I think you're only locking your tokens and then you get it back after whatever the period is. So how does that work on Handshake?
Yeah, so there's an auction system that's based on covenants. So traditionally, UTXOs have a locking script and a value. And in Handshake, the UTXO data structure, it also has this thing called a covenant, which has a type and then data. And there's a state machine that defines the auction system. And the way that it works is specific covenant types have spend patterns to other covenant types. And the consensus rules will verify that the data field is updated correctly when spent from one type to the next. So through this, an auction system is created. So at first, a user has to send an open transaction to the chain. And that signals that an auction is going to open. And that can only happen after the name rolls out. So like I said earlier, a name rolls out after the hash of the name, mod 52. That'll give you the week. And that week is represented in block height. So once that block is passed, then the name is considered rolled out. So once a user opens it, then there's some amount of time, I believe it's 37 blocks on mainnet, then the name goes into the bidding phase. And anyone on the blockchain is allowed to bid for the name during this time. And the bids are blinded. So you commit to the actual value that you're bidding. And since it's UTXO based, the value and the output, that is the maximum value that could be bid. And the commitment to the actual value that you're bidding is held in the covenant data field. And then a certain number of blocks pass, and then the auction switches to the reveal phase. And then during the reveal phase, all bidders must reveal their bids. And the auction system is set up so that it's a second order auction or a victory auction. Basically, what that means is that the winner pays the amount of the second highest bidder. And after the auction, the winner, those coins are burned. They're spent into the UTXO that represents that name, and you cannot spend that value out. So they're technically burned.
And those tokens are the handshake tokens that you're describing.
Yep.
So you actually are paying for it. You're like buying it. You're losing that money that you spent in the auction.
Yeah, you're turning it into the name.
Yeah.
And only for a period of time?
Yeah, you must renew once every 2 years.
Okay.
And it's really easy to renew. You just send a renewal transaction to the blockchain, and it just needs to be included in a block. There's a consensus rule that limits the number of renewals per block, and that kind of creates a fee pressure. Because one kind of problem with Bitcoin is that in the long term, we're uncertain whether or not it'll be able to sustain itself directly on fees. So this renewal mechanism helps to incentivize transactions over time. And since only a certain amount of renewals can fit within a single block, then there's going to be competition for that block space, which hopefully will help to drive miner revenue through transaction fees.
How long do I have to renew?
Oh, yeah. So you have 2 years to renew.
Oh, you can renew right after you claim it?
Yeah, you can renew really whenever. You just need to do it within 2 years.
And a renewal is, aside from the fee, free to do.
Yeah, besides the fee.
So it's kind of a different. So like in a normal domain system, you buy the domain, costs $20 for a year, and then you have about a month to pay your next invoice, and it costs another $20 to buy for another year. So here it's sort of there's this auction to get it in the first place. But once you have it, you're more or less guaranteed to be able to keep it.
And if you don't renew, then the name will go back up for auction.
Yeah.
What we just talked about was the auction with these tokens, this handshake tokens. What we wanted to talk about as well was this airdrop and token distribution, like how these tokens were actually handed out, how one would get them. So let's go back to maybe the beginning there, like of that story. So like there was a white paper, there was a team, you were building Handshake. What was your token distribution plan? How did that come together? Because I know it's been highlighted as kind of a unique one.
So public keys were scraped from the internet and basically all committed to when the blockchain started. And Handshake coins are being airdropped to all of those keys.
Does that mean like when you say that all public keys?
So the biggest source of these keys was they were basically scraped from GitHub. So a script was used to basically query GitHub, and it looked for GitHub users with 15 followers, at least 15 followers, and a valid SSH key or PGP key, as well as other keys like from the PGP Web of Trust, from Keybase, if you had a Hacker News account attached to it. So all of these keys were all collected, and then they were all committed to in a giant Urkel tree, and that tree root is part of Handshake consensus. And if you can provide a proof to the blockchain that you own one of those keys, then you can claim your airdrop.
Does everybody know that?
So not many people know that outside of kind of the blockchain space, because a really small percentage of those total airdrops have been collected. It's the majority of the coin supply has been airdropped. So I believe it's 70% of the total supply has been airdropped through this mechanism. So the idea is to distribute the currency as widely as possible and kind of experiment in seeing if the people that have received the airdrop are able to coordinate and push the project forward as an alternative to, say, having a central organization try to coordinate and push the project forward.
Who developed this concept? Was this in the organizing team, or was there, I mean, I know the answer, but was there help?
Yeah, totally. So the organizing team, they implemented it, but Dan Benet and Riyad Wabi over at Stanford, they came up with a signature scheme called Goose Egg. So Goose Egg is a signature scheme where it's basically a zero knowledge proof over an RSA private key where you do not need to reveal the public key. And the reason why this is really important is because if you think of all of these keys being scraped from the internet, it would destroy the fungibility of the Handshake coin itself, because if everyone had to reveal their public keys as they're claiming their airdrop, then it would seed the transaction graph with the real world identities of who's claiming these coins. So that's why it's really important to have a privacy preserving airdrop when you're using keys that are attached to real world names.
And this is interesting because, I mean, this airdrop favors just general contributors to technology, I guess, if you're using GitHub as sort of a basis. I guess one question I have to follow that up, though, is what happens to those who will develop over the next 4 years and they were too young to be participating in this one? Do you plan another one, or is it like continuous?
So there was just one airdrop. The white paper does hint a little bit at a possible community-driven second airdrop where the community could coordinate to, agree upon airdropping again and selectively targeting who to airdrop to. And through another airdrop, if it causes the value of the network to go up enough, then potentially everyone would agree on doing another airdrop. But that's just mentioned in the white paper, and I have no idea if that would ever happen.
Are contributors to the project also paid with these tokens? Like, is there an earn possibility from it or no?
I mean, I think it would be really cool to set up some sort of business that earned revenue in Handshake. I would definitely be interested in working on a project that did that. But it is a proof of work based blockchain. So all of the new subsidy, the inflation,
the mining rewards.
It's the mining. Yeah.
Yeah, it would be interesting to try to combine some treasury model with, instead of burning the tokens, send some portion of the tokens to treasury that can go out to either new airdrops or to pay contributors or to buy. So I really love the idea of, you're trying to attract a certain type of person, a developer-y type of person with the airdrop, right? To get early buy-in, to get an early community that can contribute technically. But there's a second wave that I think makes sense to try to airdrop to, and that's journalists, lawyers, people who actually need a decentralized naming system. Because one of the core problems of ICANN is that they're basically controlled by the US government. If the US government comes knocking, they will take down your domain. There's no questions asked. And so this has happened to many journalists. It's happened to many people around the world for good and bad reasons. But there's a huge community of people who aren't that interested in it technically, but would be great users of the system, if you know what I mean. So taking some of those auction money and sending it to those people would be interesting. But yeah, pure speculation.
Yeah, no, people in the Handshake community have actually spoken about what to do with those locked coins that are locked in the names. We kind of call them burned right now. But people have talked about ideas of what to do with those coins in the long term. And who knows, maybe there will be a proposal that does propose something like that. And you are right in the sense of there are other important types of people that could use the airdrop, like journalists and lawyers and kind of influencers, people that would want to use it. And also, I mean, Trump is tweeting about how he wants to go off against Twitter, and who knows what's going to happen there. Yeah, I don't want to get too off topic.
Yeah.
But
it is kind of scary when the president says he's going to take down social media. So it's okay, that's nice censorship.
Totally. So another really interesting thing about Handshake is the way that name transfers work. Since your name is locked in a UTXO, you might want to trade that name with another person. And the way that transfers work in Handshake is it requires 2 transactions to transfer. And this is kind of a game theory thing, because if your key was stolen, you don't want someone to steal your name right out from underneath you. It would be horrible if, say, a big company like Google was running on Handshake and they did something wrong and, all of a sudden now their name is gone and no one can access any of their services. So The idea with Handshake is that you have to send one transaction, which is a transfer transaction, and you commit to the address that you'll be transferring to. And at any time, you can spend from that transfer to a revoke, which burns that name. And then the name will then later go up for auction. So the idea is that it's a game theory twist that hopefully disincentivizes people from trying to steal names, because at worst, assuming that the name holder is live, at worst, the name will just be burnt and it will be a griefing attack instead of the name being stolen.
So we've mentioned it a little bit already, but there's a new, is it fair to call it a kind of Urkel Tree? I don't know. But there's this Urkel Tree. What is that and where does the name come from?
Yeah, so the name came before my time, so I don't know exactly where the name came from, but I mean, Urkel from pop culture.
He's a nerd.
Yeah, he's a nerd. It makes for good memes. There's lots of good memes in Handshake, so you should come to the Handshake community for memes. So the Urkel Tree, it's meant to be an authenticated database, and it's designed specifically after some research into the other sorts of authenticated databases that are used in the blockchain space. Ethereum's Patricia Merkle tree was originally meant to be used in Handshake, but it turned out that the proofs were too large for the client-side SPV kind of light clients that Handshake wanted to enable. So if you look in the white paper, many different kind of authenticated data structures were explored, and the Urkel tree is kind of taking little pieces from different people's work and combining it all into one.
Was it developed by the Handshake team, or does it come from other research? Does it exist as from like a university or something like that?
No, it was JJ. He came up with it and he implemented it, and it works really well.
Cool.
One of the features about it is that there's no actual database. It's all implemented over flat files, so you don't really have the overhead of the database.
It's interesting, there's so much discussion. I think like one of the most interesting parts of building a blockchain is like discussing and thinking about these tree structures. Even Vitalik has gone out and said multiple times like his biggest regret with Ethereum was the Patricia Merkle tree, and he would have gone with a binary tree if he could. So what does the Urkel tree actually look like? Like, what is this structure?
So the Urkel tree is a binary tree, and the white paper actually goes pretty in depth to how it works, but it's a binary tree and it's also a trie. So it collapses upwards, and that's to help offset and make the proof sizes smaller. One major risk with this sort of tree is that if there's many bit collisions, then it will definitely balloon the size of the proofs. The white paper goes into detail about this and talks about how Bitcoin is creating maybe like 80 bits of collision, and how if somebody grinded names like that in Handshake, it would require quite a bit of hash power to do something like that. So in the short term, we're not necessarily worried about that, but it is something to keep in mind for the long term.
I mean, the easiest way to avoid grinding attacks is use a hash function that no one else uses. So what are you using?
I believe that it's Blake 2B, 256.
Yeah. So that's something that like Bitcoin ASICs can't solve, that I don't know that anyone is using as their hash algorithm for their proof of work, which makes it unlikely that someone can really effectively grind it.
Yeah, so Handshake uses a combination of Blake 2B and SHA-3 throughout the code base, and the proof of work is a combination of some Blake 2B and some SHA-3.
So to cap off the episode, a topic that I wanted to dig back into, which we kind of started this episode on, is the adoption. And specifically, I think about there exists a DNS system. There exists a legacy system. You could view Handshake as a replacement of that system or as an extension of that system. And I guess the way you view that changes your adoption methods a little bit. But there's still so much in like, you need to run name servers, you need to run DNS resolvers, you need to run all this infrastructure. How do you get people to do that? How do you get someone like Cloudflare to do it? How do you get ISPs to, because like normal people rely on their ISPs for DNS resolution. Or like you could build it into routers. And so if you have like mainstream routers supporting this resolver, then you would get this automatically by buying a supported router. There's tons of cool options, but like what is being explored and like what is, the view from where you're sitting?
Yeah, those all sound like great opportunities for entrepreneurs to come into this space and start building things. Right now, I do know that the number of transactions per day hit an all-time high on like the 25th of May, like a couple of days ago or so. And so more and more adoption is coming through speculation right now. It's still really early in the infrastructure phase. Different people are kind of working on different projects trying to build out that infrastructure. I do know that Next DNS, they're a startup that provides DNS services. They support an experimental Handshake resolver directly in their client. So if you download their application, then you can go into their settings and click the little button that turns on Handshake resolution.
But like, is the goal extension or is the goal to replace?
Yeah, so that's a really philosophical question that I can't necessarily answer. I don't know. I mean, I think that really comes down to what happens when there's a name collision. And this is kind of happening right now in the community. And I'm finding it really interesting because we're seeing different types of people in the ecosystem kind of all coming together with different opinions. And it's just showing how diverse the Handshake community already is. So there's kind of the more anarchist type that are more interested in just replacing the current system. And then there's more kind of people coming from the traditional tech world that are more interested in kind of melding with the traditional system. So I have no idea where it's going to end up, but I think that whatever happens in the near future with this music top level domain, because music was sold on Handshake. And it was also sold through ICANN, but it does not currently exist on ICANN systems. You can't resolve any .musics, but this registrar, they went through all the paperwork, they went through everything, and they claim that they're going to be setting it up later this year. And I have no idea if that's true, but that's just what they're saying. So now the community is kind of in this battle trying to figure out what to do. As a community, do we give them the .music name on Handshake through a hard fork? That would be kind of like a DAO-like event on Ethereum. Or do we kind of make a soft fork where it kind of invalidates the current name and then allows it to go back up for re-auction? Or do you create a kind of application layer change where the DNS resolvers themselves have some sort of system where they can prefer to resolve any name either through ICANN or through Handshake? So those are some different kind of options that are being explored through the community.
This sounds really exciting. I wonder, like, where should people go if they want to understand this better or participate in this community discussion?
Totally, yeah. There's an IRC community is growing. So you can find people on Freenode, on hashtag Handshake. And then you can also find people on Telegram. If you just search for Handshake on Telegram, it'll pop up. There's a Handshake call on every Thursday. And right now it's at 12:30 Pacific, but we're flexible. We're willing to change it to kind of fit different people's schedules because we're finding that there's people coming from all around the world and stuff like that. And yeah, you can join in. You can talk to us. I've been tweeting about it.
Where is that? Where does it stream?
So right now we're streaming it on Twitch, and it's pretty fun. Everyone gets like lots of points and colored pixels flying on the screen and stuff like that. But I think long term, we'd like to kind of get something set up with like Jitsi or something like that. It's something that's open source. It would like more kind of fit the community vibe.
Cool. Well, we'll try to collect some of these links and add them in the show notes. I want to say thanks so much for coming on the show.
Yeah, awesome.
Yeah, thank you. Very interesting.
Yeah, thanks for having me. I've been listening to this show for a while now, and yeah, I really appreciate you having me on.
Cool. All right. And to our listeners, thanks for listening.
Thanks for listening.